Hi, my name is Ihsan Qazi, and today I'll be talking to you about our work on rethinking the design of the web for improving its affordability and inclusivity. This is joint work with my colleagues Zafar Qazi, Ayesha, and two of our students, Muhammad Abdullah and Rumaisa Habib. As we all know, the web has been a key enabler for development and socioeconomic mobility. Despite its tremendous success, it remains too expensive for many internet users, especially in developing countries. A World Bank survey carried out in 11 emerging countries found that a median of 48% of respondents had difficulty paying for their mobile data usage, and 42% restrict the amount of data they use. But what price of mobile broadband is affordable? The United Nations Broadband Commission for Sustainable Development has set the target for affordable broadband services at 2% or less of monthly per capita income in a country. Here is the geographical distribution of the price of a 1.5 gigabyte mobile broadband plan as a percentage of the average income across countries in the world. According to the International Telecommunication Union, 84 developing countries do not meet the affordability target. Concurrently, we are observing a steady increase in web complexity. For example, the median mobile web page size has increased from 145 kilobytes to nearly 2 megabytes in the last decade, which corresponds to a 13x increase. This in turn has increased the cost per access to a website, thereby making web services less affordable, especially for users in developing regions. So, how do we address the affordability challenge? One way to do so is to raise income levels in developing countries. However, income levels have remained stubborn. The World Bank classifies 81 countries as either low income or lower middle income. In the last year, only 4 countries have moved to a high income category, whereas 3 countries moved to the low income or low middle income category. Another way to make broadband services more affordable is to lower their price. Unfortunately, between 2019 and 2020, the median price for mobile broadband services reduced by only 0.2 percentage points, which highlights systematic barriers as the average revenue per user in developing countries is already fairly low. Finally, we can make the web affordable by reducing the web complexity in regions with high broadband prices relative to income levels. And this is the focus of our work. To this end, we present the design of a framework which we call Affordable Web for All. The Affordable Web for All framework improves affordability while ensuring good web page quality by explicitly accounting for affordability constraints in its design. The key idea of the framework is to adapt web complexity systematically based on broadband prices and income levels in a geographic region. Our framework relies on a new fairness metric called PAW, or Price Adjusted Web Access, which captures the equitability of web page accesses. We evaluate our framework using a cross-country analysis of 8 developing countries. Now let's try to understand the PAW index. PAW captures the reduction needed in the average web page size in a region to achieve the affordability target for web accesses. Here is a plot that shows the PAW index for 8 developing countries across 3 mobile broadband plans. It shows that the maximum reduction needed in the average web page size is 4.5x for data-only plans, whereas it is 12x for data and voice high usage plans. This suggests that offering low-quality versions of popular websites in these countries can bring many users within the affordability target. To quantify the benefit of reducing web complexity in meeting the affordability target, we plot the percentage of countries not meeting the web accesses target as a function of the reduction in mean web page size using data from 176 countries. We find that reducing the average page size by 1.5x allows 10 to 15% of the countries to meet the target accesses. These insights can serve as useful guides for modulating the website complexity. To explore the possibilities of achieving the target website complexities based on the PAW index, we carried out a what-if analysis based on features of Alexa top 100 websites in each of the 8 developing countries. We find that since JavaScript and images contribute the most bytes to web pages across the 8 countries, Removing them or lowering their quality can provide the greatest reductions in web page sizes that range from up to 1.9x with JavaScript to up to 2.1x with images. Given the poor value in a region, we can achieve various target complexities by applying different resource optimizations. Of particular interest are optimizations related to images and JavaScript that can save bytes without significantly degrading quality. For example, reducing image quality, transcoding images into efficient formats such as WebP and JPEG, or removing non-essential JavaScript elements. Thus, in our design, we assign priorities to optimizations based on their impact on quality. And we apply optimizations until the target complexity is met. Depending on the desired page complexity, different trade-offs emerge. For example, reducing complexity by 6x may not be possible for some pages without substantially degrading quality and functionality, whereas a complexity reduction of 1.5x is achievable in many cases without degrading quality. We can achieve equity in accesses by trading off web page size, which serves as a proxy for web page quality. Here is how Amazon's web page appears on a mobile device, and here is how a 4x reduced complexity page appears. To capture this quality access trade-off, we use the Cobb-Douglas utility function, which we model as a function of the expected number of website accesses available to a user and the average web page size in the user's region. We find that for a user to experience a utility gain, the willingness to give up quality to get more access must be greater than what the user would have to give up as a result of meeting the affordability target. Moreover, the utility gain will vary based on users' current consumption levels, income levels, and the price of broadband in their region. To quantify the quality access trade-off, we conducted a user study comprising 25 participants, details of which are available in the paper. We selected 10 websites common in Alexa top 100 in 8 developing countries. And for each website, we created 4 low complexity versions. We found that all pages remained usable for up to 1.5x reduction, 8 remained usable with 3x, and 5 pages remained usable with 6x reduction in the page size. We showed these low complexity versions to each participant and asked them to rate the page look similarity and page content similarity. The figure shows the heat map of user ratings, where lighter shades reflect greater similarity. We found that while almost all websites were rated to be quite similar to the original version at 1.5x reduction, some exhibited a good degree of similarity even at 6x reduction. Next, to gauge the relative user preferences for web page quality and web accesses, we gave users different choices of web page quality and number of monthly web accesses. The figure shows the distribution of user preferences over these choices. We find that some users preferred 600 accesses despite 6x reduction in page quality, whereas others preferred a higher quality page, even if it meant smaller web accesses. This suggests that a significant fraction of users are likely to observe a utility gain by trading off web page quality for more accesses. In terms of adoption of the framework, Affordable Web for All offers incentives for different stakeholders in the internet ecosystem. For example, for website operators, it enables the development of a differentiated web service offering, which can create a new market for reduced quality web services that can appeal to existing users who are data constrained, as well as new users who were previously unable to afford these services. This will likely increase advertising revenues for website operators. For mobile network operators, it can make it attractive to offer smaller data plans, as users can derive more value from the same number of bytes. For users, we expand the affordable consumption choice set, which should increase their utility in the long run. In summary, we propose the Affordable Web for All framework for improving web affordability and inclusivity. It relies on a new fairness metric, which we call PAW. We use PAW to generate low complexity versions of websites based on broadband price and income levels in a region. Our evaluation shows that such a framework can achieve a better balance between web page quality and affordability. With that, I thank you all.